Hey everyone, CNC Keith here. In this video, let's check out the CNC 12 PLC Diagnostic screen. Starting in version 4.64, this new app, the Acorn Simplified Input-Output PLC Diagnostic app, was introduced. So let's check out, what does it do? So what it does is shows us the state of the inputs and outputs on the Acorn board. So there's 8 inputs and 8 outputs on the Acorn board. And this little app shows us the current state of them. And it'll show us the state of them live. And we can interact with these inputs and outputs. By that, I mean I can use the mouse to click on an input or an output. And notice here in the upper right, it tells me what that input is assigned to. Well, how did this input get assigned to Home All? Well, that was in the wizard. So when you set up your inputs and outputs in the wizard, you take the various input selection that you want and you drag it over to the input that you want to assign it to, and then you would wire things accordingly. Well, once you've made those definitions in the wizard, you can use the PLC Diagnostic screen to see what's going on with those inputs. So this is a way for you to check your wiring, check the sensors, the switches, whatever you've got connected to the inputs and the outputs, live, real time. So I can use the arrow keys on the keyboard to navigate around the 8 different inputs here. I could hit down arrow and now I'm on the outputs, or I could use the mouse to click on any of them. So you can see I'm on number 4, and number 4 has been assigned to tool is unclamped, which is a sensor in an ATC spindle to verify that the tool is actually unclamped. So these are virtual LEDs. So these LEDs will indicate, both for inputs and outputs, what state it is in. And let's explore that a little bit further. So typically you like to have, whenever you can, a normally closed switch, especially for limit switches or home switches. So normally closed would be a green LED on an input. So if I have Home All set here in the wizard and to NC, so you see number 1 is set to green, which is normally closed. Normally closed means that there is a closed connection. That input is made when that switch is not tripped. So the PLC Diagnostic screen is telling me right now that, hey, input number 1 is open. That's why it's red. It should be green. If the switch is okay and the wiring is okay and it's normally closed, that switch right now in a non-trip state should make this LED green. Well, the reason why this LED is red right now is I don't have anything wired to input number 1. I assigned input 1 to be the Home All input, which is a input saving technique where you wire all 3 home switches or 4 into one input, and in this case I selected normally closed. So since I don't have anything wired there, it's red. So if you did have something wired there and it's red, that lets you know that something's wrong. You either have it wired to the wrong spot, or you don't have that daisy chain wired properly, or one of your switches is bad or tripped, etc. So this is a, as the name implies, a diagnostic tool that you can open up this menu and see the state of the inputs and see the state of the outputs. So let's just explore this a little further. Let's go down here to the outputs. Let's see what they're assigned to. So output 1 is no fault out. So no fault out is used to actuate, commonly used to actuate an e-stop contactor. So this output will trigger when there is a problem. And it could be a problem from a bunch of different sources. If a switch is tripped when we're not expecting it to be tripped, A drive OK signal from a servo drive is saying, hey, look, I've faulted. Then we issue a no fault out, which then you can then wire into an e-stop contactor that will shut everything down under an e-stop condition. Number 2 is set to router dust collection. Number 3 is set to pop-up pins. Number 4 is set to router vacuum hold down, spindle forward, spindle reverse, laser line activate, and spindle cooling fan. So all 8 here are populated. So these are all red because outputs turn green when they're active and red when they're not active. So on the relay board, you have 2 different choices on wiring. You can wire to the normally open side of the relay or the normally closed side. It depends on your application. This is not indicating that. What this is indicating is whether that relay is activated or not. Okay. So depending on how you have things wired, it's just letting you know here by a simple quick observation of whether this particular output is activated. So let's go play with it once. I'm going to turn off auto spindle and then ask it to turn the spindle on clockwise. And I'm going to turn it off. And you can see output 5 turning on and off as I turn on and off in manual mode the spindle forward. So let's go over here and let's look at number 5. So number 5, just like I have in the wizard, let's go look at it, is set the spindle forward. And then when I'm here in CNC 12 and I have the spindle set to manual, I turn it off, output 5 is deactivated, I turn it on, it's activated. So what else is going on there? I see output 8 also flashing on and off. Let's go over to output 8. What is output 8? Output 8 is the spindle cooling fan. So right now, the way that the system is set up is that whenever you turn on the spindle, the cooling fan also turns on. So that's why you see that output also turning on. So let's go counterclockwise, not too common on a router, pretty common on a milling machine, and hit cycle start there. Now we see output 6 activating. There's spindle reverse. And I'm going to turn it off. All right. Now I could also do the same thing in manual mode or in auto mode, but I can go into MDI and do an M3S 2000. And it won't let me do it because I got a drive fault. Look at the message board. So it's saying right now I have a drive fault and I can't command any automatic motion. Well, let's debug this. Let's use the PLC app to debug it. So I got a 327 job fault and a 9031 drive fault. I'm going to hit the reset button to cycle it and I'm going to try to jog. And bam! It tries to jog, but it has drive fault. Well, what's going on? Let's go up to the inputs and find drive fault. So drive fault is the drive OK signal from the axis drive. And this signal, depending on your drive, can be normally open or normally closed. Doesn't matter. It just all depends on how you have it set up. So right now, drive OK is set to normally closed. So the way the Acorn input is set up is it is expecting a closed input when there's no problems, when the servo drive or stepper drive is reporting no problems. Okay, so this is not that commonly used on stepper drives, definitely on servo drives. This is used all the time because we want an indication from the drive, especially a closed loop drive, that it is faulted out. And if it faulted out or lost position for any reason, it's going to trigger this input and let CNC 12 know. So let's use the probe app to debug what's going on. So if I look at my wiring right now, and I do have the wire properly wired to input 5, but yet it's red, that means the drive is not happy. Okay, so it's sending right now it opened that circuit to input 5, and it's saying, hey, I have a fault. So, what to do? You got to go back and check the drive and see, make sure whether it's normally closed or normally open. When it's in its happy state, that's all good. One thing you can use the PLC diagnostic screen is not only can I observe the states of the inputs and the outputs, I can also interact with them. And so what I could do, and this is usually just done in a debug state, I can actually, and you can do this in the wizard too. Let's say I accidentally assigned the drive OK to normally open or normally closed, and it should be normally open. I could test that really quick rather than going to the wizard and flipping it, which you can do. There's nothing wrong with that. I could test it really quick by clicking on it. And by clicking on it, or I can use Control-Alt-I as a shortcut on the keyboard, it does the same thing. You'll see this bar appear above the LED, and it turned green. So what I did is I just inverted it. Okay, so it's set to normally closed, but I effectively turned this into normally open by inverting input number 5. All right, so let's go, and this is live, real time. So that's why this is useful. You can very quickly debug things live. So let's go back to CNC 12 and cycle the reset button. So when I inverted this, it made an immediate effect. I cycle it to clear any faults, and all of a sudden now I can jog. So either I'm missing the wire on input 5, or the drives that I'm using are really normally open when they're happy. So that's an example here of how you would use the PLC Diagnostic app. Now, once you figure this out, you should go back to the wizard and change this to normally open and hit right settings to CNC control, because you want it set up properly in the wizard for sure. But you can use the PLC Diagnostic app here to debug things quickly. So you can observe it, change it, get it working in here, and then go back and double check your wiring, check your drives, check the wizard, and get all that set up properly. Alrighty, let me do an example of an output. So how would I interact with an output? Actually, let's go back to that MDI example. So here I am in auto mode, and when I was stopped with MDI didn't work because it had a drive fault. By definition, MDI stands for manual data input. This is automatic program control motion. So you can't have any error messages. You can't have limit switches tripped or drive OK signals be faulting out, etc. Everything's got to be good to run in MDI mode. So let's do M3 spindle clockwise S 2000 at 2000 RPM, and I hit cycle start. Bam! There you go. Look at output 5 turned on and output 8. So right now the spindle is running at 2000 RPM, and 2 outputs have turned on, number 5 and number 8. Number 5 is spindle forward, and 8 is the cooling fan. Let's type in M5 and hit cycle start, and you'll see those outputs turn off. M4, which is counterclockwise, S 2300, cycle start, and you will see 8 and 6 turn on, because 6 is the spindle reverse output. Alrighty, so there's a demonstration of observing live the Acorn PLC app for the outputs. What if I wanted to directly turn an output on or off right here with the PLC app, which you can do? So not only can you observe these just like the inputs, I can actually force an output to be on or off or in its normal state. So normal state is the way it is right now. They're either green or red. So green again is activated, red is deactivated. What if I wanted to force one of these to turn on? So let's say I'm debugging my laser wiring and I just want the laser to turn on, and then it won't turn on for some reason. Well, I can force that output on by hitting Control Alt F, which is here. That's the keyboard shortcut. Or I can just double click on it with the mouse. And we've got 3 different states going on here. So notice there's a red LED with a line, a red LED, a green LED with a line. So green LED with a line is forced on. I have forced that output on using the diagnostic app here. So right now, if I run down and I look in the cabinet, that relay and that LED is on right now. If I force it off, I just turned it off. If I get rid of the line, it's back to its usual state. What that means, it's waiting for a command from the VCP or the program, the G-code program, for that output. Now this is a great little tool to debug the wiring and the functions, or the relays, the laser, whatever you got it connected to, because you can force it on without having to program any buttons, write a G-code, nothing. You can just go right here and say, turn that output on, and it's activated. There it is. And now I can debug what I have wired to it. Now some guys get themselves in trouble, and what they do is they're playing with this, and they leave it, like I have number 8 right there, in the forced off state. And then they go back. Here, let's just force off spindle forward. I'll just give you an example. And we'll turn number 8 back on. So let's go back to manual. And I hit spindle on clockwise. And I have number 5 set to spindle forward. Watch what happens when I hit the button. 8 turns on, but 5 doesn't do anything. The reason why 5's not doing anything is I forced it off right here. It's a manual override of that output. It will not listen to a button, a G code, an M code, anything, because I have it forced off, and that's what that line means. You might say, well, why would you ever want to do that? Well, if you're debugging, let's say, an automatic tool changer, you might want to step it through the steps, but have something turned off, some aspect of it that you don't have quite wired or hooked up right. So that's one example of why you would want to force an output off. Maybe you want to run an M code or a G code program that fires an output, and you're debugging it, but you don't want that output to turn on because whatever reason, it's not wired properly, it's not completed, you don't have it connected, etc. So this is often used in the commissioning and the integration of the CNC control. Just be sure if you forced it off that you put it back to normal. And that's same with forcing it on. You can get yourself into trouble, like number 7 is forced on. So number 7, laser line activate. So right now that output is on all the time, no matter what commands I give it. Doesn't matter if I hit the button here on the VC or not, it's on all the time. That's because I have it forced on. So just double click that to cycle through the 3 choices. Here's normal, forced on, forced off, click again, back to normal. Easy peasy. Alrighty, that's an introduction to the simplified input-output screen. Let's check out what happens if I hit Alt-I again. It closes it. And if I hit Alt-I again, it brings it up. So I can use the Windows tools here to close things, or I can use the keyboard shortcut to open things. Okay, there's a few other interesting things about the PLC Diagnostic app I'd like to tell you about. If you have an Ether 1616 connected to your system, not only will you have 16 additional inputs and outputs appear here in the wizard, they will also appear right here in the PLC Diagnostic app as well, and they work exactly as they do with the first 8 inputs of the Acorn, like I've just shown you. Alrighty, so there is another PLC Diagnostic tool built into CNC 12. The one that I've been demonstrating is called the Simplified, and this is we also known as AKA the PLC Diagnostic app or the IO app. Any of those kind of words are used to describe this piece of software right here, this diagnostic screen app that we've been using in this video. There is another one built into CNC 12 that's a little bit more comprehensive, and hence that's why this one's called the Simplified, where it just shows us the inputs and the outputs. Let me go show you how to activate that. Down here in the wizard under CNC Control, the very last selection under CNC Control Preferences is enable the Simple PLC Diagnostic as the default. I'm going to say no to that and save that setting. And the wizard's going to ask me to shut down and restart CNC 12, which I'm going to do. So I'm going to shut her down, and I'm going to double click on my icon on my desktop to restart it, and then we're going to hit Alt-I from the main screen. I'm going to hit reset to clear, Alt-I, and whoa, this looks a lot different. I have a lot more LEDs and many rows of them. So what's going on? This one, you can't use the mouse in this one to click on any of the LEDs. This is 100% keyboard driven. So I'm using the arrow keys, and down here in the middle, it's telling me what input number, what input LED I'm on, and what it's defined to. So you'll notice these are the same names. These input definitions haven't changed. This is just a different piece of software here to look at the inputs and outputs, memory locations, and PLC stages all at the same time with all this data thrown at you all at once. So hence, that's why the other app is called Simplified, where this just gives you everything. If I use the arrow keys, you'll see, here are my input definitions, just like we saw in the Simplified PLC app. So let's go down and look at the output. So here we are. We have no fault out, router dust collection, pop-up pins, router hold down. And we can use the same Control-Alt-I and Control-Alt-F that I did in the Simplified version. So here with keyboards, I'm going to trigger Home All. There, I inverted it. Now I uninverted it. And all I'm doing is hitting Control-Alt-I to do that. So I'm cycling through the various. So I can manually invert an input. I can manually activate an output. So here, let's go turn the spindle cooling fan on. Control-Alt-F. There it is, forced on, forced off. There we are, back to normal. Do it again. And I'm just hitting Control-Alt-F to cycle through, just like in the Simplified PLC operation there, PLC app. So this screen also, which I'm not going to go into in this video, gives us memory location information. This is great when you're debugging a complex macro or PLC program. You can see the memory locations triggering live while you're running something. And same with the PLC stages here. You can see what's going on there. If you're writing a custom PLC program for a tool changer, this information that's being displayed here is useful. So same deal. If I want to close this down and get rid of the screen, I hit Alt-I, it goes away. I hit Alt-I, it comes back. And just to review again, to get that back to the Simplified one, I just go back in the wizard and go to CNC Control Preferences and change that to yes and reboot CNC 12. Now it'll go back to the simple one. So there you have it, the Centroid Acorn PLC Diagnostic app. Be sure to sign up for free tech support at the Centroid CNC Tech Support Forum. And visit our website for more information or to purchase directly online.